Hello, this is Rafi Ahmed, and today I'll be presenting on for foundation computing. My learner registration number is 250710017, and my study center is EduLab. Qualification is of THM Level 3 Foundation Diploma for Higher Education Studies. So let's start with the presentation. To begin with, we're going to start with contents. So we're going to cover the central processing unit. Secondly, we are going to present hardware components, then data representation, logic gates, computer network, World Wide Web, and finally network topology. So let's start with CPU, which is basically known as the central processing unit, the brain of the computer. It runs instructions and handles all the processing, so everything works smoothly. It is the main part of a computer that follows instructions, codes, and processes the data. The CPU provides us with control, speed, decision making, and processing power. So let's move on with components of the CPU. As you can see, we have the control unit, which is the part of the computer which tells other parts what to do. It also keeps track of the flow of data. It informs the RAM to get an instruction and send it to the ALU to be processed. So, what is registers and what it does? So registers are small fast memory areas of the CPU that temporarily store data and instructions. Finally, we got arithmetic logic unit that we covered previously on control unit. They sends information instructions to LU. So the LU does all of the math and logic work like adding and subtracting. So let's move on with our next part, which is functions of the CPU. So the CPU has four main jobs. First of all, it fetches. What it does fetches? It fetches the main memory, which is the RAM, sends the CPU the next instruction, and then it decodes. The CPU decodes the instruction to figure out what to do. After decoding, it executes. The CPU follows the instructions such as moving data or conducting math. Finally, it stores the information that it fetched, decoded, and executed. If necessary, the result is transmitted back to memory or saved in a register. To move on, here you can see the computer hardware components. So we're going to explain about the components, the hardware components of a computer, and explore different parts. So to start with, the motherboard is the main hub that connects all of the parts together. The CPU reads commands from the hard drive or SSD. So hard drive or SSD are both storages of a computer. So hard drive are previous generation storage hardware and SSD are the newer generation hardware, and then carries them out. The motherboard is what sends and gets data. RAM keeps the CPU's current data, like open files or programs. The CPU uses RAM to get to things rapidly instead of slower storage. And here we go for the GPU, which helps the CPU by handling images and graphics, especially while calculating math and logic, for rendering, for ray tracing, like games, videos, and 3D softwares, and other logic required softwares. So an SSD or HDD stores the long-term data, like the operating system programs and files. When opening something, it enters into RAM, so it can be used straight away. So what is storage media? Here we can see magnetic storage, optical storage. So we'll cover one by one. Let's start with the magnetic storage. Magnetic storage, data is stored on a surface in the form of magnetic patterns. The disk or tape is covered in a magnetic material. Magnetic domains are small areas that are magnetized in different ways to exhibit 1 second and 0 seconds. Optical storage, data is stored on the surface of a disk in small pits and flat areas. The way pits and lands reflect light shows binary data, 1 second and 0 second. SSD stands for solid state storage. It is a storage device that uses flash memory to store data. So how it represents data? It is done in such a way that data is stored, processed, and transferred. Computers encrypt complex data in binary, which is 0 and 1, to protect it. Binary, octal, decimal, hexadecimal, and other number systems are used to show information in a quantitative way. While encrypting data, we make it so that people with permission may read it, which is a form of secure and private way of securing data. When you use the internet, our passwords, communications, and credit card information are all safe. So how was it possible? One is the technology they use is symmetric encryption, which uses only one key to lock, which is known as encrypt, and unlock, which is called decrypt the data. In the internet era, the sender and the receiver both have the same key. And what's the second technology? It's asymmetric encryption, which employs two keys: a public key that everyone may see, and a private key that the owner retains to himself. How images and sounds are represented in computer systems. So we'll start with images. So those are pixels. Pixels are the little dots that make up the picture. There are numbers, which is usually in the computer language, which is binary 0 and 1, that inform each pixel what color it should be. Most formats employ the RGB color model. For example, 8 bits each color means that each pixel has 24 bits of color. The computer stores these color values in a grid so it can put the picture back together. So I hope you have understood the images. Let's move on to sounds. Sounds are waves that never stop. Computers capture samples of them several times a second and turn them into numbers. Each sample creates a binary number, It tells you how loud the sound wave is right now. To reach CD quality, 44,100 samples are taken every second. This is known as the sample rate. These clips sound just like the original when you play them again, since they are in the same order. So that's a long way around. Let's get to data compression. Data of all kinds can be compressed. Lossy and lossless compression are the two typical types of compression. Lossless compression, it lets us get back all of the original data after decompressing it. Lossy compression makes the file smaller, but loses some data, so the decompressed file is not an exact copy of the original. So what's the purpose of logic gates? Logic gates are small electronic devices that take in one or more inputs, typically 0 or 1, and give out one output, also 0 or 1. Truth tables can help us keep track of what a logic gate or circuit performs. So what does 0 and 1 means? 0 usually means off or false, and 1 usually means on or true in the computer language. There are 7 known logic gates. Those are AND, OR, NOT, NAND, NOR, JAR, XNOR. So the types of computer networks are personal area network, local area network, metropolitan area network, wide area network. To start off, let's start with PAN, the personal area network. It is a way to connect personal gadgets over a small distance so we can quickly share or control them. Secondly is the LAN, a local area network. It lets several devices in a limited area such as a home or office share printers, files, and the internet. Then what's metropolitan area network, which is the MAN? It connects networks across the city, is helpful for enterprises, the government, and civic services. Wide area network. It connects devices over great distances, letting people talk to each other and get to things all over the world, including the internet. Transmission media. There are 2 types of transmission mediums. One is guided media, and is data travels through physical cables. For example, for guided media, we have got twisted pair cable, coaxial cable, fiber optic cable. The second type of transmission mediums are unguided media, which is wireless. The data travels through air or space using waves, like radio waves, microwaves, and infrared. World Wide Web. The World Wide Web, or WW, or web, as you saw while browsing on internet, there's this www appears before every domain. What's that? It's a collection of public web pages that are linked to each other and may be viewed through the internet. It allows people to see and share information. The web consists of these 3 components. One is HTML, other is HTTP, and finally URL. So let's move on to computer network topology. Number 1 is bus topology. Second is star topology. Third is ring topology, mesh topology as follows, and tree topology, and finally point-to-point topology. So bus topology is the device where connected to a single central cable. Star topology are all the devices which is connected to a central device like a switch or hub. Just use mainly LANs, easy to manage and add devices. And the drawback is if the central hub fails, the network stops working. For ring topology, each device connects to exactly two others, forming a circular path. For mesh topology, every device connects directly to every other device. And for tree hierarchical topology, this is a combination of star topologies arranged in a hierarchy. And finally, we got point-to-point topology, which has a direct connection between two devices. And finally, to the conclusion, the CPU, memory, and storage are important parts of a computer. Data is saved in binary and safeguarded with encryption. Logic gates make choices, and networks connect everything using diverse shapes. All of these things make modern computers work. Thank you for watching my presentation.